So, factorising, a bit more complex than multiples, so let's get started. Factors means two numbers that go together or multiply together to get another number. So let's go the factors of, let's go 50. So the first thing, we can talk about factor pairs. So factor pairs. So what two numbers multiply to get 50? So we can think 5 and 10 multiply together. So 5 and 10 is a factor pair of 50. We could also go 1 and 50 because 1 times 50 is 50. We could also go 2 times 25 is 50. So factor pairs, two numbers that multiply together to get the given number. The other way of thinking about factors is just list all the factors. So we're thinking, what are all the numbers that divide into 50? So there's an easy way and a hard way to do factors, and I'm hoping you'll take my hint and do it the easy way. So we're always going to start with 1 and the factor pair of 50, and we're going to stretch it out like that. So this is going to be the beginning of our list and that will be the end of our list, and we're just going to be logical and sequential here. So 1 goes into 50, 1 times 50 is 50. What's the next number after 1? 2. Does 2 go into 50? Well, yes it does. 2 times 25 is 50. Both 2 and 25 divide into 50. What's after 2? 3. Does 3 go into 50? Well, actually, no, it doesn't, so we don't need it. What's after 3? 4. Does 4 go into 50? No, it doesn't, so we don't write it down. What's after 4? 5. Does 5 go into 50? Yes, it does. 5 tens are 50. So 5 and 10 make up 50. Then we're going to try 6. Does 6 go into 50? No. Does 7 go into 50? No. Does 8 go under 50? No. Clearly you guys know your times table, so this is nice and easy, isn't it? Does 9 go under 50? No. Does 10? Hang on. I've already written it down. Once you get to that stage that you've written that number down, you can stop thinking. There's no need to check 11 or 12 or 13 because you've reached another factor. And that's why this is good, because you know to stop looking. That's your list. Let's try it with another one. Let's go, what are the factors of 40? Again, we'll go 1, 40. What's after 1? 2. 2 and 20. That's a nice easy one. Does 3 go into 40? Nope. How about 4? 4 goes into 40 10 times. How about 5? 5 eighths are 40. Does 6 go in? No. Does 7 go in? No. Does 8 go in? Well, it does, but I've already written 8 down. Because I've met it, I now stop. I don't check 9, don't check 11, don't check 12, don't check any of them. I stop. So that's listing all the factors. A nice, easy way. Brings me to another term. Let's just say, and we'll get to this when we get to algebra in grade 8, we need to find the highest common factor of 40 and 50. So a little bit like the LCM, the lowest common multiple in the previous video, highest common factor. So we want to list all the factors of our two numbers, and we want the highest common, so we want the biggest number in both lists. So what's the highest common factor of 40 and 50? We're looking for the biggest number that's in both lists. So the highest common factor of 40 and 50 is 10. Highest common factor. So long as you know how to list the factors, pretty easy. One more thing with factorising before you do some practice on the practice sheets. Prime factor tree. Okay, let's think of a number. 60. Hopefully we know what prime numbers are. Prime numbers are divisible by 1 and themselves. So a prime factor tree is working out what prime numbers multiply together to get 60. So you've probably seen this done before. We're going to find a tree, and all we want is a factor pair of 60. Doesn't really matter where you start. I'm going to go with 6 and 10. When I see a prime number, I'm going to circle it and my branches are going to stop. None of them are prime, so I'm going to keep going. What two numbers make 6? 2 times 3. And what two numbers make 10? I'm going to go 2 times 5. When I do that, I'm then circling anything prime. Well, it's a nice easy one because they're all prime. What I can say from that, as soon as they're all circled, I'm going to say 2 times 3 times 2 times 5 equals 60. So this is representing 60 as a product of prime numbers. Now listen very carefully. Just to be neat, because we're mathematicians, see those two 2's? We're going to write it like that because that would be just a little bit nicer, and we like simplest form. So that is listing 60 as a product of prime numbers using a factor tree. One more thing we need to do is we need to list 60 as a product of prime numbers using index notation. See the two 2's? We can say that that is 2 squared times 3 times 5 equals 60. So it's about combining these like terms into powers. Okay, that'll do us. Go do some practice and I'm sure you'll get the hang of it, no worries at all.